Hello and welcome to another video. Today we have an MSI A520 board, A520-M A PRO on our bench, and this is an interesting case. The previous owner bought this thing new, installed it, and said it was faulty from beginning on. And when I got this board and I saw the story of it, I couldn't help myself but look around a little bit on the board if I could see anything. And I got to say the board really looks like brand new. And especially the top side, like it looks like it was never used. Like this thing, you can see nothing on it. No dust, nothing, no thermal paste. But I was able to find one thing pretty quickly, which was on the back side, when I just took it out of the box and had a look at it. And it is around, where is it? Right here. With the overhead camera, it's kind of hard to tell, but they are knocked off components. The person that bought this new destroyed it while installing it. The big question is, did he try to send it back or not? And was that discovered? That is a very interesting thing to me, because if I would have bought this thing brand new, I would have just sent it back if it doesn't work. But yeah, I do not know if that person has tried that or not. So let's then go under the microscope and have a good look at what is actually broken there. And right here we can actually see the component. So what do I see? The original component is still here. So this thing needs just some resoldering, but all of its passives have been knocked off. I don't think there was anything here. I think we're missing one there, one there, one there, so 3. A fourth one there and a fifth one there. Probably all resistors. And these two, I think, were also not fitted. So we need to resolder these and need to find what components belong here. So this was that obvious that I was able to see this with a blank eye when I just took it out and had a little look around the board, because this area is, yeah, it had gotten quite some damage. So, we need a board view for this. And I get asked very often how I get my board views. For MSI, it's mostly really easy. We find this number right here, MS7C96 version 1.1. Then let me show you what you can do. So, we're currently on Google. We type in MS7C96 and then, for example, schematic. And then we can see this is a similar schematic, because this is a revision 1.0. 7, or is it 7C96? I think it is 7C96, right? Let me see again. Yeah, this should be 7C96, and we need revision 1.1. Let's see. Yeah, there's only paid schematics as I can see it. But instead of schematic, let's type in board view. And then there are a few archives of Telegram, for example. You could look this up. What else is there? Is there bad caps? No, bad caps has a different one only. Okay. So most of the time what I do actually is this site, for example, I've used a lot to get schematics actually. This is, for example, not the correct one, but they probably have this version that we need. And you can only pay them via crypto in order to get funds on here. So this is what I do as well. Or for example, on this side as well, you can also only pay via crypto in order to get funds here and then buy them. Because if Bad Caps doesn't have it, like the first point I would always send people would be Bad Caps. So if you search MS7C96, let's see, buys and schematic request. Let's see if they have it here. This is for this is a BIOS. No, and sadly no. Sadly nothing. And yeah, this is kind of unlucky. That if Bad Caps is like the first point where I would go in order to search, but sadly there isn't anything here to go for. So yeah, this is what I would do most of the time, and then I would just go through the links. So I will now continue to search who has it. Like in a Facebook group, for example, there's a board view. Don't know if you need to pay for it or not. But yeah, I would just go through the links, see who has what I need, and yeah, go from there then. So, and if you cannot find these via the just Googling for them, you can also go to the Discord of either Electronics Repair School or Learner Electronics Repair. There's also Northwest Repair that also has a Discord for schematic requests. Let me show you. All three of these channels have Discord servers where you can put down schematic requests. And that is where I put people most of the time in order to find schematics. And one more service that I have been using is called XZZ. This is a Chinese software where you need to pay a monthly fee. I think it's about $6 that you need to pay, and you get an application that connects to their servers, and you can actually then see a lot of board views. Like they have a lot of board views. Like they are the one of the ones that have like the newest iPhones and some stuff like that very early on. And they have drones and everything, and they have a lot of main boards as well. And I've been using their service for some time as well. I just don't like their this is how the software then looks. You have on the left side, you actually have where to go, and then you can find all of these schematics. I just don't like their board viewer. Their board viewer kind of looks like this here, and it's not that easy to use. Yeah, but they provide a bigger collection of board views and schematics for really not too high of a price. So yeah, I would actually also recommend them, but the problem is it's Chinese software that you need to log into. You can pay via PayPal, which is great, and it does work, but you have to install the software. They have to connect their servers and so on and so forth. So yeah, make your own choice of that. Maybe get a laptop that only does that. Maybe, who knows? I installed this on my main machine and I didn't have any problems. So yeah. And so I have acquired this schematic, and let's now see what this actually is. NCT 3933. Okay, this takes, interesting, 5-volt DIMM, SDS data, 0 S clock, DDR over voltage. Okay, interesting. Where does this go? I'm just kind of interested what we're actually missing. Like, what kind of implication this would have. Okay, so this is for the RT8231. This probably, yeah, this works for feedback. Okay, yeah, this is for the VDDQ, so the controller for the memory voltage. This is one line that goes to there. Interesting. Let's see, what else can we find on this chip? This seems like a clock line, but it does not seem to be connected. A data line that also does not seem to be connected. What else is there on this chip? A ground and another signal that takes the 5 volts. Okay. And another one here. Kind of hard to tell what this thing actually does. Okay, this signal does go to, because this is a supply signal. But where does this one go? This on this side. Also, that takes the 5 volts and then to ground. Some kind of feedbacking. Interesting. I kind of cannot tell what this really does. Oh, this is just... Oh, yeah, okay. This is DDR over voltage. Okay, this is for looking up that the DDR actually has the voltage that it needs. Oh, okay. Okay. Got it. So the DDR voltage will probably never start if this isn't there. So if this is not working. So let's see then what kind of resistors we're missing, because these here are not fitted, just like I thought. Then let's see, this is a 13k ohm. Okay, 13k ohms will be kind of difficult to find. 18k ohm, just like 18k ohm is not that easy to find. That's capacitor, 0.1 microfarad, 16 volts. That is the usual one that is on the PCIe standard. So this is easy to find. Let's see, this and this one isn't fitted just like we thought. 4.7K is a standard that is not hard, and another 4.7K. Okay, these two are easy to find, and the capacitor is easy to find, but I will have to take a look if I can find a 13 and an 18K ohm resistor. So let me look up if I can find that on any of my donor boards. So, actually I was able to find on a donor board the exact same thing on an MSI board. So we have an 18K ohm resistor right here, and we have a 13K ohm resistor right here. There will probably then be 4.7K somewhere here as well, right? No, this is a 47K. Let's see if there's anything like that near to here. So I wasn't able to find 4.7K near here, but there's also a 0.1 microfarad 16 volts, so we can take all three of those, and 4.7Ks I have new ones. So let's go ahead and take off all of these, but first we will have to prepare the position of the on the receiving board, that there's actually leaded solder everywhere, and we can put these resistors on there. So let's go over back to the microscope. So let's see right here. Let's get some flux into this place where we actually have some components, and let's get the main component as well. Let's take a decent sized soldering tip, some leaded solder, and let's prepare this place. So I always start with getting rid of all of the old stuff. So because there's often like parts of the old components left, you need to scrape them off. Need a little bit more temperature on my soldering iron. And then let's also resolder this chip here, so that all of the connections are definitely good. It could be that we need to replace the chip, but I think it actually looks fine enough, where the legs still held on good enough in order for us to reuse this chip. So all of the places are prepared now. So 4.7K is here, the capacitor here. I think the 18K there and the 13K there. Oh no, the 13K here and the 18K there. Yep. So let's go to the donor board and get those components off of there. So right here on the donor board is what we need. We can see the same chip, and that is the 13 and the 18K right here, the resistors, and also one of the capacitors that we need. So I like to put leaded solder onto them so they remove easier. This donor board is toast, so I will definitely heat up the DDR socket that is there, but I don't really care. So let me see what resistor is what, so I know where to put it. So the upper one is the 18K and the lower one is the 13K. So let's take the upper one off first, and then I'll try to put it basically instantly where we need it on the receiving board. There it is off. Let me put it into place. So let's go instantly over to the receiving board so that I can put it into the right place, and then we go on with taking the other components so I don't lose them or mix them up. So where did it land? I just put it down. There. There it is. Like the flux that I use gums up really easily as soon as you have like soldered anything to it at one point. But that's okay. There we are. One side is soldered on. I think I need to raise the temperature on my soldering iron because the tip is clean, but I really cannot get enough heat into there. So let's go over then get the 13K ohm one. So there's the resistor off. Let's also take the capacitor instantly off of here while the board is still hot. So all of the components are now in place. And yeah, you can see they are just soldered on one side like I like to do it. And now we just take the hot air and we heat up everything at once. And yeah, with the Flux that I use, if you don't use hot air, it gums up easily and it's really unpleasant to see, or like hard to see what you do. But yeah, let's now hot air everything into place. So it should basically, most of the components should just move on their own into where they need to be. So let's all give them all a little nudge like that. And everything is in place. Let's see for our big component that the legs are not shorting. Okay, yeah, the legs of that bit component were really bent. I didn't see that before. I only saw that now. We could reuse it. Like, they are bent, but you can definitely solder to it again. But because I have it on a donor board, I'm just going to take it off and put it onto here. Because, yeah, I do have it. Let's just make it proper. Use a component that is in good condition and put that onto here. So let's quickly take that off. I still have the component, like it flew off right there, but yeah, it's still on my bench here. But we're not going to use it because let me see if I can show you. Like the legs are bent in one direction. Right here. This side that you can see, the legs are bent away. And you can definitely make that work, but I'd rather just use a working component and yeah, or like in a component that is in good condition. Just so hot air it off of here and yeah, be done with it. So let's apply leaded solder to these legs just a little bit everywhere, that it removes easier. So let's blast it off of here and hope that the capacitor that is lower to it doesn't blow up in my face. There's the component off. Let's see, I don't quite remember what way it was on, to be perfectly honest. Probably like this. Let me check the board view, where pin 1 needs to be, because I don't think it's marked anywhere. I cannot see like anything. There's like the outline of the chip, but I don't think there's anything. Oh, well, there's a marking right here on this side, but I don't know what that would mean. It probably is like this. But let me check the board view for a quick second. So pin 1 is at the top right. So I would expect this then to sit the other way around. So like that. So let's then get it tacked down just a little bit. So just connect one leg, put some flux onto them, and then I just reflow it into place. So let's take the hot air, make big circles around it, heat it up slowly, that I don't blow it away, and that it just goes into place. So like that, the chip is in place, and now we get rid of these short circuits. Let's take some solder wick. So I took off a little bit too much solder, so let's put some back. And just like that, it should be all fine. Let's now clean up the area. So now our area is nice and rebuilt. Everything is there again, all of the resistors. Let's now check for the resistances of these, just to be sure that we put them into the right place. So the left one is supposed to be the 13K, and it climbs up. There's probably something in parallel to it, so that's why it shows 8K. So let's go to this one. This was supposed to be the 18K. Yeah, it shows the same one because it's parallel to it. Okay. Yeah, we can't really see them because it's in circuit, and in circuit you cannot measure them. And these are 4.7 each. These ones we took new ones. So yeah, I think it will be fine. It should be like that, even though we can't confirm it because yeah, it's in circuit. But I'm pretty sure we put them on the right way before. So let's then turn this board over and get it built up and see actually if it now works or not. So the board is fully set up. Let's now see at its passive power consumption and see if this was all that this board needed. Because like I said, I only glanced over it with the naked eye, so not under the microscope. Oh, 230 milliamps. That is way too hot. Did I put it on backwards? No way I put it on backwards, right? Because that just drew 230 milliamps and that is too much. I will have to see for the footage. Let me reverse the footage once more and see if I didn't put that chip on backwards, because that was too much power draw. That was 230 milliamps in passive mode. So let me quickly have a look. So I just checked the footage and I'm pretty sure I have it on the right way. Like with the dot to the top left, top right. Let's quickly check that, but I'm pretty sure I did put it on the right way. Let's see right here. Go on the microscope. Yes, it's on the right way. Huh. Weird. And nothing else is shorting here. Interesting. Let's check the resistance then of this. And let's check what the power consumption is if I have nothing attached to it also. So let's go into the overview. So resistance checks on the 24 pin. Let's go to the 5 VSB. It's 750 ohms. I wouldn't expect any problems. Okay, let's check the others. Kilo ohm on 3.3. Kilo ohms on 12 volts. 320 ohms on 5 volts. Interesting. Okay, let's check 3 VSB. 3 VSB has kilo ohms. Let's see if I can find the 5 volt dual. 5 volt dual has kilo ohms. Let's check. There's another 5 volt VDIM. Also kilo ohms. Okay, what was drawing so much power just then? The 12 volts. Kilo ohms. 12 volts into the phase. Also kilo ohms. Okay, let's check some of the inductors for like passive rails for like 1.8 and 0.9, but they also have high resistance. The VDDQ itself also has high resistance. What was drawing so much power? Everything has good resistances. There's the one for the PCH, also, or like the 2.5 volts, also good resistance. A USB one, also good resistance. Like what? How? What drew so much power right there? Okay, let's see that again. I want to quickly see that again. If it draws so much power. So let's see. Yeah, it goes from 80 milliamps to 230 milliamps. Very weird. Because I don't think it should do that. Let me get a thermal camera out, because before just starting this board up, I want to make very sure that we don't fry anything here. So I got the thermal camera set up. The thing is that 230 milliamps is just so much power draw. I need to quickly find out what this is. There's something there heating up, but not really much. 30 degrees only. Okay, let me check the backside. Not that the component that we put on is actually drawing so much. No, it's not the component. There's something. Yeah, this is only 27 degrees. There's nothing burning. Okay. Interesting. Why is it drawing so much power then? Because 230 milliamps is so much. And if we check the front, there is really the only thing that is heating up a little bit is a controller right there. That might be for the 3 VSB, but it's really cold. It's like 27 degrees. That's nothing. Well then, if nothing is getting overly hot, like yeah, only the 3.3 volt regulator, 31 degrees, but nothing else. Let's check the let's check some voltages then in standby mode, just to be sure. And let's leave it at the 230 milliamps, because, yeah, we cannot see anything like burning. So let's see, 3.3 volts seems fine. Let's see, 5 volt dual. 5 volt dual is there. Another 5 volts for the DDR. That seems not to be present, but that might be normal in standby mode. Let's see right here. No, also not. Okay, let's see, 0.9 volts and 1.8 volts. So 0.9 volts does not seem to be present right here, but I'm not too sure if it should be currently in this mode. Yeah, I guess we just go for the press of the power button and then see from there, because there's nothing getting hot right here. Like, there's no problems that I can see so far with the board. Nothing heating up too much, even though the power consumption is really high. Okay, let's then see what happens when we press the power button. So, press of the power button. It does go some... Okay, my software froze. Okay, interesting. I didn't have that happen before. Let me restart my software. Okay, I've never had that happen before, actually. That this thing actually froze. So let's try again. 230 milliamps, it's moving. Turning on 1.4 amps, 1.7. It looks like the power consumption looks good. We are on a DRAM LED. VGA LED. So everything seems fine. It just boots normally. Let me put a GPU into here. And we will monitor it with the thermal camera while it's booting up, just to be sure. So I have the thermal camera right here. Let's boot this up once more. So it's booting. But I cannot see a singular heat spot. What you want to be looking out for is something that gets overly hot compared to everything else. But it seems to be fine. Like, everything is heating up pretty equally. Where we are on a VGA LED currently. Let's see if we get a picture actually out of this. Yeah, just like the hottest part that my camera sees is like around 30 degrees, which is nothing. Yeah, 33 degrees. So nothing to worry about. All of this looks fine. Okay, let's put this to the side, because we're still on a VGA LED for some reason. And the question is now, why are we not booting? We probably will have to reset the BIOS of here. Yeah, the board is definitely not on. Okay, let's turn this off. It's off now. And now the passive power consumption is also normal, 83 milliamps. Okay, interesting. Let's remove the GPU. Let's remove the BIOS battery. So BIOS battery is out. There's a JBET header right next to it. I will short that. And let's see, I don't see a clear CMOS header itself. It doesn't have a button on the back. So I will just short the 2 pins that I see. And also the battery connector, and should be fine. Press the power button a few times so the board is actually drained of everything. And then let's see again if a reset of a BIOS will get us over the VGA LED. Because this is a 3100. This should definitely be supported by this board. So let's see right here. Board turns on. And we basically instantly... No, we go CPU DRAM LED. Okay. Oh, so we're currently stuck on DRAM. So the question is now, is our 1.2 volts running or not? Okay. Before we go to check some voltage, I'm just going to use the other DDR slot just to replug the RAM once or twice. And yeah, see like that, if that is maybe the only problem that we have here. So let's go again. So CPU LED. Okay. Turns off. 3 amps, 4 amps, that looks good. 2.4 amps. DRAM goes out, 3 amps. Now it looks better. Now I could actually see something. 3 amps again. VGA LED, 2.2 amps. 2 amps, 2.4. Drop in power consumption is a good sign. Let's see. Do we get a BIOS screen? Almost 4 amps. stuck on a VGA LED. But the current is jumping, which is probably because of the GPU that I have here, that it doesn't like it. It probably has to restart a couple of times. So let's give it some time, lean back, and I actually think this will post and give us a picture any second now. And there's the picture. Very good. Very, very good. So that was all that this board was missing, probably. Let me get that picture on here. Probably have to press F1 to get into setup. Let's see, there we are. And there's the actual BIOS. Whew, okay, this board has a BIOS of, what is that, October 23. So definitely have to do a BIOS flash. But let's get this into Windows. I want to put both sticks of RAM into here. And let me put the BIOS battery in here, so the actual BIOS isn't being reset after we've now booted it. So putting in another stick of RAM, putting in an M.2 in order to get into Windows, and then check if everything is working in Windows as well, like the USB and the Ethernet and the audio. Let's see if it goes into Windows. And yeah, seems to be that that was everything. That knocked off component of the back for the over voltage protection of the DDR. That actually happens quite frequently, that people try to put in boards and like new boards, and then they're just not working, and they send them back or instantly try to sell them. And when I read the story, I already thought to myself that it's probably going to be physical damage, just from experience. And we're stuck on a DRAM LED again because of that stick that I put into there. Let me take that out and in a couple of times so that the board can actually boot. Because I'm pretty sure it's just there. It's not broken data connections or anything. It's just probably a dirty slot or dirty RAM. Okay, this board is trolling me. It does not want to boot with that one stick in there. In the first slot. I will have to see why. I probably have to clean it. Let me quickly do that and get you back as soon as I got it. I can't believe it. There's actually a missing data line right there. It's hard to see, but that LED where my finger is in front of it is not on, and it doesn't come on when you wiggle it. So there's probably some damage on the backside. I thought this repair was already done, but it seems like there is a ripped trace somewhere, and we will have to find it. It's probably on the backside as well, close to where we were working before. But I didn't expect there to be more damage on the spot, to be perfectly honest. But it does make sense, because that area looked quite bad that was damaged. So let's go under the microscope once more in order to find that broken through trace, repair it, and then get both sticks of RAM working in here. So let's see. I would start somewhere close to where this damage actually was. So let's see. So there's this right here. Let's see if this is actually broken through or not. So we will have to expose it a little bit. So I'm pretty sure this is not it, because this one looks fairly clean. Let's, what always helps is to put IPA on it and clean that off. Yeah, that trace is fine, pretty surely. This trace is fine. So it's not the one that we're searching for. So let's continue our search then. Is there anything damaged here? No. We might need to find what trace actually is broken and go from there. I would have expected it's kind of obvious to see, but it appears not. So far everything looking clean. Or we might actually have to see what data line that is broken here in order to narrow down where we have to look. But I would have expected it to be obvious, to be honest. But pretty sure it should be this one, because the one that is not working is the closer one to the CPU, and it appears that all of the data lines are running on this side of the board. So I actually cannot see any damage. I would have expected that the damage is somewhere close to this thing. Like somewhere in this region where we have just scraped that one back and tried it, but yeah, there's nothing. There's a little bit more there, but that also isn't a break. And none of these pins seems to be damaged themselves. Well, then I haven't done this in a while, but we will have to actually find out which data line is broken and see for that. So I would have expected it to be like something here, to be perfectly honest. But they still look fine. Like, this one looks a little bit scratched, but I don't think it's broken through, just like that one isn't broken through. Well then, let's actually see for the data line tester what data line it says that is broken and find that. So the one that is missing is A16. A16, okay. Let's then, we know it's A16. Let's go on the back of the data line tester, because it has basically a table that tells you which pin it is. So let's search for A16 somewhere. Let me quickly find it. There, A16. A16 is pin 82. Okay, so let's search in the board view for pin 82. So in the board view, let's search. On this DIMM, we need pin 82, which is right here in the middle. Okay. So the third one from the top in the middle row, closer to the CPU socket, pin 82. Okay, let's go on the board then. So right here, it's the inner third one. So it should be this one right there. Let's follow this trace. Oh, I just lost it, but I think it should be somewhere here. But I don't see any break in it. Did I not find the correct one? I think... Is it... pretty sure it's supposed to be this one. Okay, no, I cannot see a break in that. Let me get into a schematic and see once again. I will have to make some... I have to look deeper into this. I cannot believe it. The board is now turning on with 2 DIMMs. What actually happened was that there was just bad connection between the socket and my CPU. Like, all there was was probably some dirt in either the socket or on my CPU, and that was why the data line was missing. So I just reseated the CPU and everything works well now. That is such a rookie mistake to make. To not just, first of all, do the easiest thing and just reseat the CPU instead of trying to trace the data line with the schematic and everything and trying to find a fault that isn't there. That is, learn from my mistakes, people. Learn from my mistakes. That's why we're here. That's why we are here to learn from each other. And take that one with you from me, so you don't have to do that mistake yourself and waste so much time on a fault that is not there. Well then. So here we are in Windows now. Everything's working well. We got Ethernet, we got audio, USB is working, both DIMMs are working. And yeah, pretty happy with this repair now, even though it took like 20 minutes or like 30 minutes longer than it needed to. But I will be flashing the BIOS on here so that this board has the newest BIOS and the newest processors can be put into here. And yeah, this was all that it was. One of the most common causes of motherboards to fail, which is physical damage. And yeah, even though on one of these boards that is like, this board is basically new. Like the I/O bracket is still packaged. This board is really brand new, and that was the only damage. And when I heard something like that, I instantly knew it had to be that. Because the boards get tested in their labs, or like in their factories when they left the factory, and they should be working. Like, the most common error sits in front of the PC or in front of the screen. That is one saying that is here in Germany. And yeah. So, I hope you enjoyed this repair, I hope you learned something. All of my tools, as always, are linked in the video description. If you want to get one of these current meters, email me in my, I have that linked in my video description. Thank you very much for watching. This was Mainboard Medic. Thank you very much, and goodbye.